This video looks at converting in between or converting within the metric system. So here's an example of a distance from the Earth to the Moon. And that number is 38,440,300,000 centimeters. Now we know the Moon's a long ways away, but if I ask you to try to understand that number, how big that number is, or how far that number is, that would be very difficult. And one of the reasons it's difficult is because the unit of measurement, in this case, a centimeter, is not appropriate. A centimeter is the width of your finger, and if you try to imagine building that number by just going the width of a finger and then putting another one, that would be a ridiculous thing to think about. So one of the things we have to be able to do is to understand these measures or numbers that we're generating, and distances or lengths are a lot easier to understand if we have an appropriate unit of measure. So the Moon's a really long way away from the Earth, and we would really want our biggest unit. And based on what we did yesterday, the biggest unit of measure we're going to worry about is a kilometer. Remember what the kilometer was? Kilometer was that distance across the Second Narrows Bridge. So even a kilometer, which we would think is, it's pretty far distance, it's not really far when you talk about how far away the Moon is, but it's the best one we have. So we're going to look at converting, basic conversions, but with the understanding that it actually helps you understand things better by changing numbers and units to more appropriate numbers and units. So there's two methods we're going to look at: bouncing along a number line and unit analysis. Unit analysis is big in science. Bouncing along a number line is a really visual, pictorial, simple way to understand something. So in the SI, the first thing you need to know is your units. And I'm always going to put small on the left-hand side and big on the right-hand side. And the smallest unit we know is millimeters, and the biggest unit we know is kilometers, and in the middle there are meters. And I'm going to put the units we care about in. I said yesterday I really only care about millimeters, centimeters, meters, and kilometers. I really don't care about decimeters, decameters, hectometers, other than they are placeholders. So it's really important that that we always use this picture. This is the only one we're going to have to worry about. And in doing converting using a number line, really all we have to do is use this picture. And once we have this picture, here's what we're going to do. We're going to identify our start, and I'm always going to call it S. So we're going to identify the start. We're going to identify what we want to change our units into, and I'll call that the finish. And we're going to identify the direction. Now, the direction should be obvious because if you put an S and an F, but we're going to identify the direction with an arrow. And in doing that, calculations turn out to be really easy. And remember, everything has to be done on a calculator. The numbers might be big. So here's what's going to happen. When we go in this direction, we're always going to be dividing by 10. So again, we know that there are 10 millimeters in a centimeter, there are 100 centimeters in a meter, there are 1,000 meters in a kilometer. So those are all based on powers of 10, but the really nice thing about bouncing along a number line, all you have to do is count how many bounces you do. And if you bounce to the right, you're going to be dividing, and if you bounce to the left, we're going to be multiplying, and we'll talk about that later on in the video. So here's the methodology of bouncing along a number line. It's really nice, it's really easy, it's visual, it's good. And then we're going to finish off the calculator. Okay, unit analysis. is almost the same idea, other than we're not going to have a visual. We're gonna have a start and a finish, just like above. But here's the nice thing about unit analysis: we always multiply. And with the imperial, or with the metric system, well, we're always going to multiply by some sort of 10. So in unit analysis, it's important that you know your basic conversion factors. And by basic conversion factors, I mean 10 millimeters in 1 centimeter, 100 centimeters in 1 meter, and 1,000 meters in 1 kilometer. Those are the basic ones that we need to worry about. And again, when we're doing our homework or when we're doing our classwork, it's a good idea to have a conversion piece of paper, so you're not having to think too much. You can just look over and take off the conversion factor you want. So the general idea of unit analysis is, when we go from start to finish, what we really want to do is we want to cancel out units. And we want to, again, cancel out units, and I'm going to put top and bottom, and this is going to make more sense when we do some examples, but we want to cancel out units until we get the unit we want. So for example, if we were going to go from centimeters to kilometers, well, I need to get rid of centimeters somehow and end up with kilometers, but I'm going to have to do a few things in between. But the nice thing about the in-between is it's always going to be a multiplication. So let's look at two examples to illustrate both methods, and ultimately I want you to be comfortable with one of them. So in this example right here, we're going to convert 100 millimeters to centimeters. And again, it all starts off on a number line by knowing this basic picture. Then what we're going to do is we're going to highlight our start, which is millimeters. I really don't care about the numbers right now. And we're going to highlight our finish, and we're going to highlight the direction we're going. And the direction we're going is that way. And I'm going to put a little extra thing here. So our direction is here. And I'm just going to put a little extra thing, and I'm going to call it a bounce. So we're going to start with millimeters. We're going to finish with centimeters. We're going to the right. And in this case, I'm only going one bounce. So what I'm going to do is every one of those bounces, if I'm going to the right, is a divide by 10. So remember on the previous page, we said going to the right is dividing and going to the left is multiplying. So now that I have my start, my finish, and I know how many bounces I'm doing, now I'm just going to get my calculator out, and I'm going to start at 100, and I'm going to divide because I'm going to the right, and I'm going to divide by 10 because I'm only going by one bounce. Again, so this one right here represents this just single 10 represents one bounce to the right. And when we do that, well, of course, 100 divided by 10 is 10. And finally, we're going to put our units. So the nice thing about a number line, a unit line, is you never care about the units until the very end. So again, remember to put the units of measure in at the end. All right? And the nice thing is we don't care about them anywhere through. Well, unit analysis, it's all about the units. And here's what I mean about the start and the finish. So when we do our unit analysis, it's all about multiplication. Everything's multiplication. It's all about canceling units. The only way to cancel a unit is if you have the unit on top and the unit on the bottom. So where we're going to start in this example is we're going to start with millimeters. I'm going to leave the numbers out right now. And where I want to finish is I want to finish with centimeters. And what's going to happen in the middle is I'm going to multiply by a conversion factor. Remember, 10 millimeters in a centimeter, 100 centimeters in a kilometer, etc. I'm going to multiply in such a way that the numbers get canceled out. So that's the basic idea. So again, we're always going to multiply. That's the good thing about unit analysis. We're always going to multiply. You don't have to worry about what direction you're going. You just have to worry about the units canceling out. So here we start off with 100 millimeters. And given that I have a millimeter, I'll put it over 1 for right now. And given that I have a millimeter on top, I have to cancel that out with a millimeter on the bottom. And the only conversion factor I know that has millimeters in it are the centimeters and millimeters. So I'm going to write that relationship, and I'm also going to write the numbers that go along with it. 1 centimeter is equal to 10 millimeters. And here's what we mean about crossing out until you get to where we want. Well, again, I have my millimeters on top and my millimeters on the bottom, and they cancel out. And look what I'm left over with. I'm left over with what I actually want. So in this one, it's really just a one-step problem. And in doing the one-step problem, I get the units I want. I've gotten rid of those other units I started with, and now I can simply get out my calculator. So what you would do is you'd get out your calculator and you would enter exactly as I'm writing. 100 times 1 over 10. Another way of writing 1 over 10 is 1 divided by 10. And when you hit the enter button, your calculator is going to spit out a 10. So this is the idea. This is the idea of canceling out units, multiplying all the time, knowing your conversion factors, and just put the unit that you want to cancel out on the bottom and the conversion factor that you know, the other unit on the top, and make sure you put the numbers in the right place. And that's having that little sense of what a number is. Okay, let's do one more example. Let's do that example we started off, because there are a few more steps here. So in this one right here, again, we're going to put our units that we know, and it always looks like this. We're going to put our start in centimeters. We're going to put our finish in kilometers and our direction that way. And then we're going to do our bounces. 1, 2, 3, 4, 5. We're doing 5 bounces. So remember, every bounce is a divide by 10. Every single bounce is either a multiplier or a divide by 10. So given that we have this picture on our number line, now we don't care about the units at all. We just care about the numbers. So I'm going to write the numbers down, but you would be doing this on your calculator. So there's our start, and all we would have to do is divide by 10 5 times, because that's how many bounces we have. And then when we hit the equal sign, we're going to get 384,403. And the only thing you have to be careful about is we always have to remember the units, because that's our start. I don't care about units until the very end. So there's advantages and disadvantages of both methods. Okay, unit analysis then. Well, this one right here is just a little bit trickier than the one before. Now remember, unit analysis, we put our start. So I'm going to put the number in. And when we do unit analysis, we also care about the units. So over here, I want to get to kilometers. Here's my start. Here's my finish. And I have to do that multiplication in between. So the first unit I want to get rid of is a centimeter. And I have a relationship between meters and centimeters. And the relationship is 1 meter is 100 centimeters. Now, the nice thing about this is we cancel out. We're left with meters. But I don't want meters. I want kilometers. So I'm going to have to do another step. And again, I want to get rid of meters, so I put the meters on the bottom. And do I know a relationship? And I do. I know that there's a relationship between kilometers and meters. And I know that 1 kilometer is equal to 1,000 meters. And when I go ahead and I cancel out my meters, finally, the only unit I have left over is kilometers. So in this case, I am where I want to go. And what I would simply do is I'd multiply that big number Okay, I'm just gonna put this down here like this. We're gonna multiply that times 1 divided by 100, and we're gonna multiply that by 1 divided by 1,000. And when we do that, we get the exact same answer we had above, 384,403 kilometers. Now that's a huge distance, but at least that number is a lot smaller. So there's two examples of conversions. And the key idea for you then is I would like you to know both. But generally, you're going to be comfortable with one method. And your science teacher is gonna know is that your science teacher is gonna want you to know unit analysis, and it is a nice way. But for me, whatever works for you. So again, the other important idea is I'd like you to start to make let's call it a cheat sheet, and it's not. It's for you. Make a cheat sheet and put your conversions on there. And what I will allow you to do is come test time, I'll allow you to use your sheet